Welcome to our Math 154 videos. This video is going to be on implicit differentiation, and I have two things to remember up here. First, that when you're doing implicit differentiation, you need to treat y as a differentiable function of x. So that means when we take the derivative of y, we're going to need to use the chain rule because y is actually a function. The second is that dy dx is equivalent to y prime. So some professors will write dy dx, some professors will write y prime. My preference is to write it in the prime notation, but both are equivalent, so don't let that confuse you if it looks a little bit different than you're used to. So we're going to go ahead and find y prime if tangent of xy plus x squared y is equal to e to the y. So first we're going to start taking the derivative because we're not going to be able to explicitly solve for y. So when we take the derivative of the tangent of xy, that's going to become secant squared of xy. But because of the chain rule, we're going to need to now take the derivative of xy. Well, that's a product, x times y. So we're going to start off with x and then take the derivative of y. Well, the derivative of y with respect to x, because y is a differentiable function of x, is y prime, or dy dx. Derivative of y with respect to x. So that's the first times the derivative of the second for our product rule. Now we need to add to it the second, which is y, times the derivative of x. The derivative of x is just 1, so we just have y there. Alright, now let's move on to this next term. We have an x squared y. So that's going to be a product rule again. So let's go ahead and put our x squared there and take our derivative of y. Well, the derivative of y with respect to x is y prime, or dy dx. And we're going to add to it y times the derivative of x squared. So that's going to be a 2xy because the derivative of x squared is 2x and we have a y there. So that completes that product rule. Now we're going to go on to the other side. So that's equal to the derivative of e to the y with respect to x. So we're first going to take the derivative of e to some power. So that's going to be e to the y. But y is a differentiable function of x. So the derivative of e to the y is not e to the y. Rather, we're going to use the chain rule and multiply this by the derivative of y, which is y prime. Okay, that's the derivative of y with respect to x. That's because when we have a function raised to the power of a function that's not the one we're differentiating with respect to, we use the chain rule. Like if this was e to the x squared, then we would have to multiply by the derivative of x squared. It's the same chain rule we've seen before, except now we have y as a function of x, so we need to take the derivative as y prime. Now the next strategy for implicit differentiation is we need to get everything with a y prime on one side and everything else on the other. So in order to do that, we're going to have to distribute the secant, or secant squared. So let's go ahead and do that. Secant squared of xy times our xy prime. So actually I'm going to write that in the front, it just looks better. Xy prime, secant squared of xy, then plus a y times a secant squared of xy, then plus all the rest of the stuff we have, x squared y prime plus 2xy. Alright, so now we're going to need to shift things over. So we'll leave this xy prime secant squared of xy on the left, and this x squared y prime will also stay on the left. Then our e to the y prime, we need to move over to the left, so we're going to subtract it. E to the y times y prime. And then that's equal to, well, we're going to subtract our terms that don't have a y prime over to the other side. There's two of them. I'm going to circle them. So we're going to subtract our y secant squared of xy. And I'm just going to add parentheses up here that I didn't have before, just because it looks nicer. And then we're going to subtract as well our 2xy. So now we have everything with a y prime on the left and everything without a y prime on the right. So good. We can factor out our y prime now. So we have x secant squared of xy plus x squared minus e to the y, and that all equal to the right hand side, which I'll write down really fast here. Alright, we're really close. Now we just need to divide to get y prime by itself. So y prime is equal to our right hand side, which is y secant squared of xy minus 2xy, then all over this big chunk right here. So we have x secant squared of xy plus x squared minus e to the y. And there you have it. We have solved for y prime by using implicit differentiation. So here's our second example, and we're going to do the same thing, find y prime. So let's go ahead and start. So first we have this e to the xy. So again, we're going to take the derivative of e to the xy, which is just e to the xy, and then by the chain rule, we need to take the derivative of that exponent xy. So x times y is a product, so we're going to have a product rule here. So first, we'll keep our x, and then we need to multiply by the derivative of y. Well, the derivative of y with respect to x is either dy dx or y prime. I'm going to write it as y prime, but remember dy dx is the same thing as y prime. Then we are going to add to it our y times the derivative of x. Well, the derivative of x is, with respect to x, is just 1. So that's it for that product rule. And now we're going to move on to our next term, sine of y. Well, the derivative of sine with respect to x is cosine, but we have a y here instead of an x, so we're going to need to use the chain rule, and that means we're going to multiply by the derivative of y. The derivative of y is y prime. I'm going to write it out in the front because it just looks a little bit nicer, and that's it for that term. Now the derivative of 1 with respect to x is 0, so we can just forget about that 1. And then we have this y cubed of x to worry about, and I'm going to pull the negative way out in front. So y cubed times x is another product. However, the y cubed is now another chain rule because we have a cube and y is a function of x. So let's go ahead and take the derivative of that chunk. So we'll go ahead and keep our y prime, or keep our y cubed, and then multiply by the derivative of x. Well, that's just 1, so that completes the first half of the product rule. Now we need to take the derivative of y cubed and multiply it by x. So the derivative of y cubed is going to be 3y squared, but then y is a differentiable function of x, so we need to take the derivative of y with respect to x as well. So that's going to be our y prime. So now, using the same strategy as before, we're going to distribute these and then try and get everything with a y prime on one side and everything else on the other side. So distributing this e to the xy, we get an xy prime e to the xy plus a y e to the xy plus a y prime cosine of y. Then that's equal to our negative y cubed minus 3xy squared y prime. And I'm writing the 3 in front just because it's standard to write the constant first. Now xy prime, e to the xy, that has a y prime in it. So does y prime cosine of y. And this term does not have a y prime in it, so we're going to subtract it to the other side. And this term does not have a y prime in it, so it's actually going to stay on that side. But our last term here, we're going to add 3xy squared y prime. Alright, now all our y primes are on one side, and now we're going to subtract that y e to the xy over to the other side, so now we have everything that has a y on one side and y prime on the other side. So now we can factor out our y prime, and we'll get x e to the xy plus a cosine of y, then plus a 3xy squared, and that's equal to our everything that we had actually the last time. Nothing changes on the right. Alright, so now we get a y prime is equal to our right side minus y e to the xy minus y cubed all over the stuff we had on the left. So x e to the xy, then plus a cosine of y plus 3xy squared. Extend that bar over, and that's it. If we wanted to in this numerator, we could factor out a y, but it looks fine like that. No need to make it any more complicated, and that is our answer.